السلام عليكم ورحمة الله. كل عام وأنتم بخير ونتمنى السلامة للجميع. أهلا وسهلا بكم في كورس ديناميكا الحرارية. The textbook for this course suggested concept in thermal physics, the second edition, last Stephen from Oxford. Maybe we can use other references like thermodynamic and engineering approach 5th edition, Bolts, and physics for scientists and engineers 8th edition, La Serwe. Okay. In this course, the objective for this course, we have to learn to state the 4 laws of thermodynamics. And we will describe and contrast the concept of empirical temperature, ideal gas temperature, kinetic temperature, and thermodynamic temperature. Also, we analyze reversible process represented in PV diagram in terms of work done and heat flow by use of the first law of thermodynamics. And we describe the heat engines, heat pumps, and refrigerators and calculate their figures or merit from their cycle representation in PV diagram. In addition, we will learn to understand how the second law of thermodynamics limits the efficiency of all engines and evaluate them this maximum efficiency for Carnot engine. And we will appreciate the macroscopic definition of entropy and relate it to disorder at the molecular level through Boltzmann hypothesis, and apply the laws of thermodynamics to physical process occurring in simple fluids, ideal, paramagnetic, elastic substance, and cavity radiation. And we will use the mathematics for partial differential to derive Maxwell relation and other thermodynamic identities. Derive the ideal gas law and the Maxwell-Boltzmann velocity distribution for gas starts from molecular kinetic assumption, and describe how diffusion and heat conduction take place at molecular level and express the rule of the mean free path in such a transport phenomena. In this course, we will cover some topics: introduction to fluids, phase of matter, density, specific gravity, fluid, pressure, atmospheric pressure, Pascal principle, hydraulic lift, barometer, open tube, manometer. And also, we will cover the atomic theory, temperature, and ideal gas law, atomic theory, Brownian motion, temperature, zero law of thermodynamics, thermal expansion, ideal gas law, Avogadro hypothesis, and number. In kinetic theory and van der Waals equation, kinetic molecular theory of gases, average translational kinetic energy, root mean square velocity, mean free path, van der Waals equation, Maxwell distribution. And also we will cover the heat and calorimeters, heat, internal energy, specific heat, calorimeters, heat of fusion, heat of vibrations, and latent heat. Also, we will cover the first law of thermodynamics in isothermal, isobaric, isovolumetric, and adiabatic process, equipartition principle of energy, molar specific heat, thermal conduction, and convection and radiation. The second law of thermodynamics, heat engine and engine efficiency, Carnot engine and reversible process, Otto cycle and reversible heat engines. The third law of thermodynamic, entropy, and summary of the fourth laws of thermodynamics. Also the statistical, maybe we will cover if we have time, the statistical mechanics of an ideal gas and the chemical potential. Okay, as we will show in the introduction, so we have goes to introduction of this course, and we will start from the fluids. What is the fluids? Fluids, stuff that flows, simple. So fluids عبارة عن liquid gases, sand, snow or granular materials, while kernels of core are solids. They behave more like liquid when flowing through a silo, like this. It's flowing. State of matter comes in 3 states. إذا حالات المادة زي ما بنعرف إما solid, liquid or gas. So far we have only dealt with solid objects, blocks, sticks, ball, and so on. The study of fluids is more complicated because fluids are complicated since they don't have any particular shape. So إذا دراسة الفلويدز يعني أمر صعب لأنه ما إلها شكل محدد. Fluids are not rigid bodies, but Newton's law can be applied to fluids. All matter, as we know, is composed of atoms. This is the atomic hypothesis. If we imagine cutting an object into small and smaller pieces, we eventually get down to atoms. Okay, and atoms تتكون من nucleus and the electron, and the electron is the orbit. This is inside an atoms. Diameter for atoms about 10 to minus 10 meter. Acceptance of atomic hypothesis ovulated over about century from 1800 إلى 1900 ميلاد. What is the difference now between the solid, liquid, and gases? The main difference is the distance between the atoms. The atoms of solid are closer to each other than atoms in liquid. The atoms in liquid are closer to each other than atom in gas, and the strength of forces between the atoms, the force between atoms in solid are stronger than the forces between the atoms in liquids. The forces between atoms in liquid are stronger than forces between atoms in gases. Okay. This is for solid, stronger for liquid, and this for gas. The mass density بالحرف اليوناني أو نرمز لها بالحرف اليوناني اللي هي rho. Density is one way to characterize the meter. It depends on how close the atoms are to each other. The mass density is the amount of mass in a unit volume of the substance. It is measured in kilogram per cubic meter or جرام لكل سنتيمتر مكعب. جرام بير سي سي، وتساوي 1000 كيلو جرام لكل متر مكعب. 1 cubic such as 1 cubic meter, and this 1 to 1 to 1, this is 1 kilogram. A few mass density substance and density for lead about 11,000 كيلو جرام لكل متر مكعب. water 1000 كيلو جرام لكل متر مكعب. مثلا الألمنيوم 2700 كيلو جرام لكل متر مكعب. ايرون 2300 density لكيلو جرام لكل متر مكعب. ميركوري 13600 كيلو جرام لكل متر مكعب. إذا هاي بعض الدنسيتي لبعض المواد. طبعا الدنسيتي، كثافة الدنسيتي بيعتمد على عدد الأتومز. يعني بنلاحظ إنه بالهواء أقل شيء 1.25، يعني الأتومز تقريبا السبيس لا غير متماسكة. لكن مثلا بالليد 11,000. It depends how much atoms in the substance. Okay, gases. In gases, air pressure, the air molecule, oxygen and nitrogen in the box bounce around in all directions. When they hit the wall, they give it an impulse. So the average effect of many molecules hitting the wall produce a force on the wall. The size of this force depends on the surface area of the wall, which depends on the container. It makes more sense to give the force on a unit surface pressure. Then pressure equal force per unit area. P equal force divided by area, F over A. The unit of pressure is force is in Newton and the area meter square. So the unit of pressure is in Newton per meter square. 1 Newton per meter square is called 1 Pascal. Another commonly used unit is pounds per square inch, PCI. Pounds per square inch, PCI. وهاي أعتقد PCI أحيانا في الميجرمنتس للبريشر بنشوف في الوحدة PCI. These are the units on typical tires pressure gauge. إذا لما نروح بدنا العجل السيارة نروح ننفخه، فبنشوف الوحدة بالباسكال وبنشوف الوحدة بالPCI وبنشوف الوحدة بالبار. فبالتالي لازم ننتبه إحنا لما ننفخ العجل أي وحدة بدنا نستخدم وكم المطلوب. Okay. And the more molecule in the box، هذا يعني the number per unit volume، the larger the pressure. إذا كل ما كان عندنا more molecule في البوكس كل ما كان إيش عندي larger pressure. The pressure of gas is also larger if the molecule have larger speed. كمان إذا كانت السرعة عالية. At higher temperature, the molecule have more energy and thus higher speed. Thus, the pressure depends on two factors. Pressure proportional to number of density times temperature. And this is the ideal gas law. The Earth of atmosphere. The atmosphere is a thin layer of air surrounding the Earth. If the Earth were as a basketball, إذا اعتبرناها مثل طابة السلة, the atmosphere would be a thickness of sheet of paper. It extends upward to about 6 miles. It is held in place by gravity. The moon has no atmosphere because its gravity is not strong enough to hold on to one. At the Earth's surface, the pressure due to the atmosphere is about 100,000 Newton per meter square, 10 to the power 5 Newton per meter square, or just one atmosphere, 180 m. This is at the Earth's surface. Okay. Unit 1 Newton لكل متر square equal 1 Pascal. This means that over 1 square meter of surface area, the atmosphere exerts a force of 100,000 Newton per meter square times 1 meter square. And this is 100,000 Newton. This amount to about 22,500 pounds or 11 tons. This corresponds to mass of 10,000 kilogram. Why don't we see to notice this force? We typically don't feel atmospheric pressure because it is the same in all sides, inside and outside of object. For example, the pressure is the same on both sides of windows. The pressure inside our bodies is the same as the pressure outside. You feel atmospheric pressure in your ear drums when you go up mountain or an elevator to the top of a tall buildings. This is in 1965. Two teams of horses try to separate the half of sphere with the air pumps out. When under vacuum, there is about 1 ton of force holding the hemisphere together. Okay? This is لما نكون بالفراغ. There is about 1 ton force holding the hemisphere together. Atmosphere pressure in action when the air is removed from inside the gas can. Atmospheric pressure in the outside is unbalanced and crush the can. So suction cups also use atmospheric pressure to hold things together. Liquids cannot support themselves. One layer of fluid cannot exert a shear force sidewise to prevent slipping. Okay, so this is the liquids must have a container. then we must have a container for the liquid. Variation of a pressure with depth in liquid. Anybody that does scuba diving knows that the pressure increases as you dive to greater depth. The increasing water pressure with depth limit how deep submarine can go. Crash deep about 2400 feet for the US Seawolf class, about 4,000 feet of titanium. Okay, so the deeper you go, the higher the pressure. So we have the pressure atmosphere, the hypothesis volume of liquid of volume A, الاريا مضروبة بالارتفاع is at rest. Then this is the area and this is the H, the height. So we have B, pressure atmosphere, and we have pressure top, okay, and we have also pressure top مضروبة في الاريا, and we have the weight. So the force equal pressure multiply the area. Force تساوي B للاريا. إذا راح تأثر علينا two forces. في عندنا الفورس اللي هي عبارة عن pressure top مضروب في الاريا, and we have the weight هو الوزن أو الفورس, and also we have the pressure bottom مضروب بالاريا from أسفل, إذا من الأعلى والأسفل, and we have the weight. So thus the net force in the volume must equal 0. So F bottom راح تساوي F bottom راح تساوي F top زائد الويت, لأنه عندي هذول الويت والأف توب باتجاه بعض, pressure atoms فوق بالاريا بعكس بعض. So the force of bottom must be greater than of top. The pressure on the bottom is higher than the pressure on top. So pressure increase with depth. Okay. So pressure equal B atmosphere زائد rho في GH, where rho is the density of the liquid kilogram per meter square. At the surface of body of water, the pressure is 180 m. Example, 180 m equal 100,000 Pascal. Example, as we go down into the water, at what depth does the pressure double from 180 m, 100,000 Pascal, to 280 m, 2,000 Pascal. So then P pressure equal 2,000 Pascal وتساوي 100,000 Pascal plus rho GH. إذا rho GH equal 100,000 Pascal و equal 1,000 kilogram meter cube ضرب 10 meter per second square ضرب H. إذا H تقريبا بتساوي 10 متر. إذا H كم؟ عندي H حوالي 10 متر. Okay. Then how much does B increase with depth? Okay. Why does the pressure increase with the depth? This layer of fluid must support all the fluid above it, but simply the deeper you go, the more water you have pushes. Okay. This block, the block on the bottom, support all the block above. Okay. measuring the atmospheric pressure barometer. The column of liquid is held up by the pressure of the liquid. Okay, we have pressure atm, pressure atm, and we have the pressure of liquid, and we inverted the closed tube filled with the liquid, so the column of liquid is held by the pressure of the liquid in the tank near the surface. This pressure is atmospheric pressure, so the atmosphere pressure holds the liquid up. And we have another system, barometric pressure. Atmospheric pressure can support a column of water 10.3 meter high, or a column of mercury which is 13.6 times as dense as water. 30-inch high, the mercury barometer. Okay. This is Pascal process. The fluid level are the same in all each tube, regardless of their shape. Okay. And this is the end of the lecture, and thank you for attention.